Hello everyone, and thank you for attending to this video. Today, I'm going to troubleshoot a demo application that we have deployed in a Istio service mesh, and we have Kiali running on it. Thank you to the observability functionality from Istio and also Kiali. We are going to find out what is going on in this application. So first of all, I'm going to introduce you Kiali and then the application, and we're going to find out what is going on. And at the end, we're going to know the problem, the root cause of it. So let's go and see here, Kiali, this is the overview page where we can see that we have, for example, a booking for application with MTLS enabled. There's some traffic, everything is in green. Also, we have Istio deployed in the system, but there's some configurations with a warning, but nothing really huge. It's just a warning, nothing breaking over here. But today we're going to talk about those two namespaces that are a travel agency. Let's see the graph. Let's see the topology graph and see. And it's gonna be easier for me to introduce you what is this application is doing. Okay, this is the topology graph, and what we have here is that we have three portals in three different geolocalizations in Rome, in Paris, and in London that are consuming a travel agency engine. This travel agency, what it has information about cars, about insurances, flights, and hotels, and there's some discounts available probably for VIP or exclusive people over here. What is happening here? Let me switch to the version app graph. Is that we have two versions. We have version 1 and 2 for all the microservices running in the mesh, right? And the problem we have is that if we enable the response time AH, is that version 1 really differs in response time regarding to version 2. As you can see, we have 87 versus 222 and 9 milliseconds versus 226 milliseconds on version 2. And this is kind of the same for every microservice here, right? So the goal of this is to find the root cause. But first, and really business critical question is, are VIP users impacted more than the web ones? Because shouldn't be like this. VIP are the ones we should take more care to the other ones, right? So for us to define this, what we're gonna do is see the metrics related to the service, to the service pebbles. So for that, what we're gonna do is see the metrics and see the response times over the times. For that, we're gonna go to the inbound metrics. Here we have the inbound metrics. The first thing I wanna do is filter the metrics, see the response time, the request duration, group by the version of the client. So group them by the Rome, London, or Paris version of it. So VIP or web. Okay, so we have group. I'm gonna just focus on the average and see what happens. And you see that also we have enabled the traffic integration. We have traces correlated with the metrics. And the important thing here is that we can answer to the question we previously formulated, which is web users are experiencing lower response time. Because what you can see here is that the VIP ones are around 90 milliseconds on the average. However, the traces over here are are mostly on the lower part of the graph, meaning that are like taking less time. However, we have some exceptions here. So, okay, first question answer. Now what we're gonna do is understand the root cause. Go and find the root cause of it. The next step, what we are gonna see is the traces itself. We are gonna see, for example, for the car services that receive requests from Troubles and goes to different versions of Troubles. What we're gonna see is what the traces says. Here is Kiali has integrated all the traces in one page and filtered always by one service. In this case, the car service. Easily, what we can see is that there's like 3 different levels of response time. One kind of close to 3 milliseconds here. Another one close to 53 milliseconds, and another one close to 100 milliseconds. Let's see if we can see the details of one of these services. I'm gonna pause this and see the traces quiet over here. One thing what we can see is the version of each span, each service that built this request. So here what we can see is that this is card P2 asking. So this is kind of covering our hypothesis that the P2 is not performing well. And here we can see that this one is using Troubles P1. So, okay, we are on a kind of in the middle response time and see that this request is made in version 1 and version 2. Let's see if we can see one that it takes less than 50 milliseconds and it's made of 2 spans. So we see that it uses card P1 and this one uses discount P1. So it kind of makes sense that version 2 introduces a lot of delay here. So what we can do is go for a workload for a pod itself, for example, the cars V2, and observe the logs here, because in Kiali we also show the logs. Not only the application logs, but the container logs. Here is the sidecar logs. So it's really easy for us to understand 2 parts. And because every line here is really important and it's really descriptive of the behavior of the sidecar. But the important thing here is that we can see that in the application, somebody has introduced a chaos monkey delay of 50 milliseconds. So that makes sense. That's why all the requests going to V1 takes around 2-3 milliseconds, but if it involves version 2, then it raised to 50 milliseconds, right? So that was what I wanted to show for you, all the observability tools that we have for you to troubleshoot your applications with Kiali, and also thanks to all the Istio functionalities. Thank you very much. If you want more information, follow us on our channels, and I'll see you in the next video. Thank you very much.